examples of one of the tests you took and the problems that you did not have correct. Okay, on this first one, you were supposed to figure out what this simplified to, and I think it gave you something here on this other side with an x next to it like that. All right, so first off, cosecant of x, that's the same as 1 over sine, and times cotangent of x, and cotangent is the same as cosine over sine. And then by your identities, 1 minus cosine squared is the same as sine squared. And so then a sine and a second sine can get divided out of the denominator and the numerator as well. And then you're left with 1 times cosine, which is just cosine of x. And so that was the part you were supposed to enter. Next one here, it says cosine of x is equal to 2/3, and it is in quadrant 4, meaning it's here for an angle. And in that quadrant, cosine is positive, and sine is negative, and tangent is negative. And the reason that is because in just a normal quadrant, the x value is positive, which represents cosine. The y value is negative, which represents sine. And tangent is like a slope, the slope of the line that would run through here like so, or here, something, but the slope is negative. All right, so we know that cosine is 2/3, and we're supposed to figure out what sine of x over 2 is equal to. So then from your properties, you know that anything over 2 for sine is equal to plus and minus the square root of 1 minus cosine of x all over 2. And so we know that cosine of x is 2/3. So then we can say plus and minus the square root of 1 minus 2/3 over 2. And simplifying this ugly piece here, that would be like plus and minus the square root of 1/2 minus 1/3. And so then you just have to remember how to add fractions and do all of that good stuff. And so common denominator is 6. Numerator would be 3 minus 2/6. Still the square root leaves you with 1/6. And it's still the square root of it. And now it's not both plus and minus because you have to just figure out, since it's in quadrant 4, the initial angle, and in quadrant 4, sine is negative. So therefore, this answer would be as well. All right, here we're doing cosine of 2a equals cosine squared of a minus sine squared of a. Now, there's a property that shows you this, or if you wanted to go about and try to prove it, you'd say cosine of 2a, or not 2a, cosine of a plus a. And then by your addition property identity, cosine of a plus a would be the same as cosine a times cosine of a. minus sine of A and sine of A. And then sine times sine and cosine times cosine are the squares of both of them. So then you would get cosine squared minus sine squared. All right. Moving on to the next one. Here you were supposed to figure out what had to be put inside the parentheses on the left-hand side. And so you take these two things on the right-hand side and let's distribute them. So secant times secant is secant squared minus 1. Because when you take the negative 1 times secant, you get a negative secant. And 1 times secant is a positive secant. And those wash each other out. So you're left with that. Secant squared of x minus 1. And then if you look at the properties of trig, then secant squared of x minus 1 can convert to tangent squared. Alright, so now sine is a negative 3/5. And we're in quadrant 3, so that puts us over here. And you should know that in this quadrant, sine is negative. And so is cosine. So then tangent of 2x is the same as 2 tan of x and 1 minus tangent squared of x. Now we know that sine is a negative 3/5, so we got to figure out what tangent of x is equal to. And the easiest way to figure out anything dealing with sine, cosine, and tangent, if you know one of the other ones, is to construct yourself by looking right triangle. Let's call this angle x. Doesn't matter which angle you pick for x, just don't pick the right one. So I guess it kind of matters. You either pick this one or that one. So if you're dealing with sine of x, sine, the ratio for sine is opposite over hypotenuse. So then this becomes a number, and that that leg becomes the hypotenuse. And so since we have 3/5 here, this would be 3, and that would be 5. Don't worry about the negative sign, that's all covered here. And so since this is 3 and that is 5 by your Pythagorean theorem, the other side has to be 4. And therefore, since we're dealing with tangent of x, we know that then tangent of x equals 3/4. Now, in this quadrant, tangent is positive because it has a positive slope. So it's a plus 3/4. And so then you would have 2 times 3/4 over 1 minus 3/4. And then you just have to go through some math and get that down to a nice looking fraction instead of this pile. So you can divide the 2 out, turn it 2, then you get 3/2. and that's the 9 over 16, and 1 minus 9 is 7. No, not 7. This would be 16 over 16. Minus 9 over 16 would get you 7 over 16. And then dividing by a fraction is the same as multiplying by the reciprocal. So then you would have 3 halves times 16 over 7. You should get 24 over 7 for the answer. Moving on to the next one, trying to solve this. Well, if you look back at the last problem and recognize anything, that right there is the same as tangent to tan of x. So then you have 2 tan x equals the square root of 3. Then, no, that's not right. Let me change that. Not 2 tan x. It represents tangent 2x. Yes, so 2 tan x over 1 minus tangent squared of x is the same as tangent of 2x. All right, so then, solving for x, you got to get rid of the tangent first, and get rid of tangent, you use inverse tangent. So you have 2x equals inverse tangent square root of 3. So then, inverse tangent of the square root of 3 is at 60 degrees, or pi over 3. And that would be like here. And then tangent repeats itself every pi. So then you say plus pi. Then 2 pi n, I should say. Last thing you then have to do is divide by 2. So it's 2 pi. No, that's multiplying by 2. Dividing by 2, it's pi over 6 plus pi n. Because you have to divide both parts of that by. So there's a solution to it. All right, with this one, it says you're given some stuff in an equation or a story, and you have to substitute the values in, and it's 100 equals 36 squared over 4.9 times sine theta cosine theta. All right, and then if you take this thing and simplify it, you're going to get somewhere in the vicinity of 264.4. And then this looks very similar to 2 sine theta cosine theta. So then if we keep that as 100, you would take 138.2 times sine theta. Some bad math skills right there. Sorry about that. 132.2 sine theta cosine theta. I think that's what the answer was asking for. All right. And sine of A minus B, you don't have to prove that that is equal to something. Well, from your properties of sine, subtracting, that is the same as sine of A cosine of B minus cosine of A sine of B. And I think that's all the further you can go with that. And I do believe that was the last one of an example for you to look at. So hopefully this helps, and I will reset the test for you here in a moment.